Hello, today I will introduce about a nuisance in the greenhouse, remove biofilm. Plant greenhouses using dripping lines or hydroponic systems to provide the plants with sufficient water. However, invisible from the outside, a biofilm may build up on the inner lining of these water systems. Such biofilm may significantly reduce the water flow or even physically clog entire drippers, and may provide an ideal hiding place for plant pathogens. The buildup of a biofilm typically starts with the attachment of a single microorganism cell in suspension onto a surface. For example, the inner surface of a water line. So the biofilm inside a line is not just a slimy layer, but actually a well-structured and highly organized microbial community. This process is accelerated by the relatively high temperatures and organic soil typically present in irrigation water, and further stimulated by relatively low flow volumes at start of culture. Traditional disinfectants like chlorine may disinfect the water itself, but do not remove the biofilm and form harmful residues. Intrahydropure is a silver-stabilized hydrogen peroxide solution that both disinfects the water, but also physically removes the biofilm from the inner lining. The study described in this article clearly visualizes its functionality under experimental test conditions. Intracare has developed a biofilm generator as a model to study the natural growth and subsequent removal of biofilm with intrahydropure in an experimental setup. Plastic tubes representing the drinking water lines were filled with fusarium-contaminated water to mimic the spread of a model greenhouse pathogens. Water quality was determined by measuring the amount of ATP as a marker for microorganisms using the intra-clean quick scan in relative light units. When the growing biofilm was clearly visible by eye, then water ATP measurements started to stabilize. The continuous addition of 40 ppm intrahydropure was started to investigate its effect on the biofilm. From the start of the experiment, a gradual formation of a biofilm was noticed by eye, resulting in a clearly visible greasy layer in the inner lining of the tubing and insert. This visible biofilm completely disappeared from all surfaces after the continuous addition of intrahydropure was started. After the continuous addition of intrahydropure, the allele count rapidly decreased within a short time frame and remained low, as the measurement in week 19 shows with an allele value of 66. The ATP measurements are in line with the total allele count from the water and the insert. Both counts rapidly increased within weeks to 18 million-fold and 1.5 million-fold increase respectively. The subsequent continuous addition of intrahydropure quickly resulted in log 7 and log 6 decrease, demonstrating the fast and effective removal of microbiological contamination from the surface of the insert and inner lining of the tubes. Many botanical diseases are actually caused by fungi. Therefore, the presence and elimination of fungi in the water and biofilm was additionally visualized on fungal culture growth plates before and after treatment with intrahydropure. The presence and elimination of plant pathogenic Fusarium spp was confirmed using microbiotechnological techniques. The biofilm generator clearly demonstrated the fast and effective removal of this biofilm with the continuous addition of 40 ppm intrahydropure. This setup created a worst-case situation by the intentional addition of polluted water containing a mixture of pathogens, allowing the growth and development of a pathogenous biofilm. However, in practice, it is common use to clean and disinfect the entire water system at crop changing with 1 to 3% intrahydropure. Thank you for your attention.